Now waves are present all around us. The light which helps you to see is a wave. The sound that you hear, it is also a wave. Waves are there in your kitchen. Heat is a wave. It is an infrared wave. The microwave, it functions on a kind of a wave. Your remote controls, which operates your air conditioners, your TV, they also operate on waves. So wave is a very common thing which is present all around us, and this is something which makes our day-to-day life very easy and interesting. So let us see what we have in this chapter. So this chapter is about the basics of wave. In this chapter, we are going to understand the wavelength of wave, the frequency of wave, and the speed of wave. The next chapter will be talking about transverse, longitudinal wave. We'll be also talking about wavefronts, reflection, refraction, diffraction in this entire very interesting chapter of wave. So let us start with the basics. So let us start by understanding the different things that you should know about the wave. Right now, if you look at the screen, you see a lot of different kind of information given, right? So it will not make much sense. Let us take up things one at a time. So the first things first, can you identify where is the wave on the screen? You're right, this blue curve that you see here, the blue sinusoidal curve is your wave. Let us understand the different things that you should be knowing about any wave. The first thing that you should know about any wave is crest. Do you see the crest here? So what is a crest? This point here is your crest. Crest is the tip of a wave. Similarly, you have so many other tips as well. I'm pointing out so many other tips with my red pen. They are all your crest. This is your crest. Here this red point is also your crest. This is also your crest. So tip of the waves are called the crest. Please do remember. Similarly, the depressions or the bottommost point is called your troughs. So if you see, one of the trough is marked here clearly. Similarly, this is your trough. Trough. So crest and trough, you should be very clear on the understanding what is a crest, what is a trough. The next thing we need to look at is this red line. Do you see a red line passing through the center of the wave? The red line, very important to identify this red line. Why? Because it is kind of cutting the wave into equal halves. Right? If you can locate the red line, it is important that it should be your first starting point when you're defining the amplitude. So what is amplitude? Amplitude is the distance from your center line. If you see, the amplitude is marked here. Amplitude is the distance from the center line to the crest, or it is the distance from the center line to the trough. Both of them are your amplitude. This is your amplitude. This is also your amplitude, because the center line, this center line, which center line I am talking about, this is your center line. A center line divides the wave into two halves, right? Therefore, the distance from the center line to the trough should be equal to the distance of the center line to the trough. And these two distances, they are called the amplitude. Whenever you have to find the amplitude, what should be your first point of discussion? Your first point that you should always think about is to find the center line. What is the mistake that many students do in the examination? Say that they are given a wave like this. Say that the question paper has not given any center line is not given, and the question paper asks them to mark the amplitude. Many times the student mark the amplitude as something like this, from distance from the crest to the trough. No. So always do remember, the first thing that you have to do is you have to draw the center line, then the distance from the crest to the trough is your amplitude. This is wrong. Or the distance from the trough to the center line is your amplitude. These two are correct answers. So amplitude done, center line done, understanding of the trough and the crest is done. Alright, so let me put a tick mark. We have understood this. We have understood the crest, the trough. The center line is also called the undisturbed position. So many terms here on this screen we have already understood. Now the last thing that remains to be understood is the wavelength. So what is wavelength? What is the wavelength? Let me show you. I had put this arrow here, a movable arrow. The wavelength is the distance from one crest to the other crest. So this is a movable arrow. If you see, it is pointing from one crest to the other crest. This is known as the wavelength. One wavelength is equal to the distance from one crest to the other crest, and this distance is the same all throughout the wave. If I am putting the arrow, if you see, if I am putting my movable arrow from another crest to the next crest, again it is the same. It is the same. It is the wavelength can also be defined as the distance from one trough to the other trough, or you can say that the wavelength is the distance between consecutive troughs or consecutive crest. Consecutive means lying one next to other. It is, the wavelength is not the distance from one crest here to the other crest all the way here. The distance between consecutive crest is a wavelength. The crests which are next to one another is a wavelength, right? So if you see, this distance is the same even if I am moving this arrow between troughs and troughs, it is the same, right? That's the property of the wave that you should know about. The distance between the troughs and the distance between the crest is a constant, which is called the wavelength. Alright, one more slight important thing to understand. Say that one bit of the wave or one small portion of the wave looks something like this, as it is in this box. So if you look inside this transparent blue box, you have a small segment of the wave. This small segment of the wave, if you see, it is getting repeated again and again. How do we understand? The segment that is inside it is getting repeated in the next box, which is adjacent to it, right? This segment of the wave, same pattern you see in the next box, so on and so forth. If we place this box next to this, if you see, the same pattern is getting repeated again and again. The same pattern gets repeated again and again. That's the property of the wave that you should be knowing about, that the wave disturbances are repeated set of patterns, right? If we start the box from anywhere else, if we start the wave from here, how does the wave look like? Let me trace the wave. It looks something like this. And if we put the next box just adjacent to it, look at the pattern inside this next box. It is also precisely the same pattern. Same pattern is getting repeated again and again. Precisely the same pattern you'll see in the adjacent box. So slightly curved down, going up, slightly curved down, going up, going down, and then going up. Same disturbances, same set of pattern getting repeated. No matter where you place these two boxes, you'll see that the adjacent boxes will contain exactly same repeated patterns, right? So wavelength, one more small understanding of wavelength. Wavelength is not just the distance from the crest to crest or the trough to trough. Wavelength, you can also say, is the distance between two same points on the wave. So if you look at these 2 points, I am marking these 2 points. That's a 1 point, another point. So that's your wave. That's one set of wave, another set of wave, right? If you see, I hope you are understanding what I am trying to say. So all these red marks are similar points. All these red marks, red crosses that I have put on the waves, they are similar points of the wave, and the distance between them is the same. So that's small understanding that you need to have. This wavelength is the distance between two similar points on the wave. This is your wavelength, this is your wavelength, or it is always the same. Either you say that the wavelength is the distance between crest and crest, because crest and crest are the similar point, or you say that the wavelength is the distance between trough and trough, because trough and trough are the similar points, or you say that wavelength is the distance between two similar points of the wave. Everything, all the 3 definitions of wavelength are precisely correct. So the wave equation, what is the wave equation? It is simple. It is an equation which links the speed of the wave, the frequency of the wave, and the wavelength of the wave. So let me read this point. The speed, the frequency, and the wavelength of any set of waves are linked by this equation. So you need to remember this equation. It is speed is equal to frequency times the wavelength. You all have understood wavelength a while ago. What is wavelength? Wavelength is the distance from crest to crest or trough to trough. So you know what is wavelength. What is the speed? Speed of the wave? How fast the wave moves. We know that light travels quite fast, right? And the speed of the light is a constant number, which is 3 times 10 to the power 8 meters per second. That's the speed of light. Different waves might travel at different speed. So here speed means the speed of the wave. The speed I have written here is for an example for you all to understand that the speed of the light is this much. What is the frequency? What is the frequency of the wave? The frequency of the wave is the number of waves produced per second. Right? Let me write down the definition. What is meant by the frequency? Frequency is, you all can make notes along with me, number of waves produced in 1 second. Another term that you need to be aware of is the time period of the wave. Time period means the time for one complete wave or time for one complete oscillation. Time period, T is your time period. Time period is the time for one oscillation or one cycle of wave. So if you are given a wave, say, so what is one cycle? Cycle is the distance between same set of points on the wave. That's your one cycle. All the way from this point to this point is your one cycle. So this is your one set of wave. The time taken for one cycle is your time period. Now there is an equation. The frequency and the time period are related. Frequency is equal to 1 over time period. This is also one equation that you need to be aware of. If frequency is 1 over time period, what should be the unit of frequency? So we know the formula for the frequency. So what should be the unit for frequency? The unit for time would be, time period would be seconds. The unit for time periods, the time period would always have a unit of second, right? SI unit for time is second. So from this formula, what should be the unit of frequency? The unit for frequency should be 1 over second. 1 over second is same as hertz. 1 over second is same as hertz. Either you write the unit of frequency as 1 over seconds or hertz means the same thing. Right? So now that we have understood frequency as well, we have understood all the 3 points here. We have understood speed, frequency and wavelength. Please do remember that the formula that connects these 3 entities is V is equal to F times lambda. This is not a difficult formula to remember. Why? Even if you forget that how these quantities are connected, it is always very simple to recall. Many times students, they tend to get confused in the examination if it is V is equal to F lambda or F is equal to V lambda or lambda is equal to F times V. Students get confused between these. So which one is the correct one? Which one is the correct one? Substitute the units. It's simple. Substitute the units. Here, what is the unit of speed? Meters per second. It should be equal to the unit on the other side. The unit on the left hand side should be equal to the unit on the right hand side. What is the unit of frequency? We have just identified. It is 1 over seconds. What should be the unit of wavelength? Wavelength is a length, point to point. All the lengths are measured in meters. Meters, right? All the lengths are measured in meters. Now compare the units on both the sides. It is meters per second here. It is meters per second on the other side as well. 1 over second multiplied by meter is same as meters per second. So you have meters per second here on the left, meters per second on the right. So which justifies which formula is correct? V is equal to F lambda. V is equal to F lambda is correct because physics is a vast syllabus, right? It is but natural to make these tiny mistakes in the exam. It is all okay to forget the formula, but whenever you forget the formula, always do remember that SI units come to your rescue to justify and to quickly recall what should be the correct formula. So memorization works, but sometimes we tend to forget, and it is natural, right? So you should just know the tricks and tactics of recalling what should be the correct formula. So V is equal to F lambda is the correct formula, where speed we all know, the SI unit is meters per second, frequency is hertz. Hertz is same as 1 over seconds and the wavelength is meters. Alright, so this was all about the basics of wave. In the next chapter, we'll be talking about the transverse and the longitudinal wave.